All right, so we are going to, some of this will be a review. For some of you, some of this today will not be a review, but what's not a review won't be that bad, okay? And then tomorrow we're going to touch on more things that are not necessarily a review, but just very lightly so that you have a basic understanding so that you could probably figure out some questions, okay? If you come across them, that sort of thing. But we're going to start with basic trig review, like the geometry trig. For some of you, you haven't seen it since geometry, and for some of you, what the heck? Geometry might not have learned much depending on whatever situation, especially if you were forced to take it during the summer. That's a soapbox for another day. Bad, real bad. But it's not your fault. That's what you have to keep reminding yourself. It's not your fault. It's the situation that you're in. But all right, so trigonometry. It is the study of the relationships among the sides and angle measures in triangles. Trigonometry literally means triangle measure. Okay, that's how the words get put together. We have things called trigonometric ratios, and ratio for math just screams fraction. We also have trigonometric functions. That isn't really much that I have seen on the SAT stuff, so we're not going to get into that today. But we are going to review on what we should have learned in geometry. So if we look here at this triangle, for as far as you're concerned for right now, trig only applies to right triangles. That is not 100% a true statement. We can use it for a lot of things, but as far as what you know from what most of you have learned at this point and what you would apply it on the SAT, we're only looking at right triangles. So if you don't know how to apply it to things other than right triangles, don't do it because you're not going to get it right. All right. The only reason I care about having a right angle is that tells me I have a right triangle. The next thing I look at is that I have two other angles. Now, how many total degrees are in a triangle? 180. So if this takes up 90 of them, then the two remaining angles have to be acute and have to add to give me 90. Okay, that's an important part of some of the relationships you might see. But then I identify the angle, and it'll either be labeled for you or you're labeling it yourself or whatever, but clearly this is the angle. And what does this little symbol mean? It's a Greek letter. Which one is it? If somebody at that table over there doesn't answer, I'm going to lose my mind. What is that? Thank you. Theta. Okay, so it's theta. It's a Greek letter. It's just a variable. If I was doing an official trig lesson, we would talk about the Greek alphabet and stuff. It's possible you could see other Greek letters on the SAT. If you see some weird symbol that you could replace with an X and it would be fine, replace it with an X and move on. It doesn't matter for the question whether you know what it is or not, okay? But I do want you to know this one's theta. All right, so then we label the triangle. Now I know it's already labeled, but I'm not going to actually ask this question because I always get the same answer, because I usually ask, how do I know which side is the hypotenuse? And the answer I always get is it's the longest side, which is a true statement. However, it is a property. It's not what makes it the hypotenuse. The definition of a hypotenuse and what makes it the hypotenuse is that it's the side across from the right angle. Across from the right angle, that's what makes it the longest side. You with me? So we still need to know it's the longest side, but it's across from, because I don't have any numbers, how do I know which one's the longest? You can't go by the way it looks. So across from the right angle, this is my hypotenuse. We're going to label it H. You okay? Yeah. Is trig killing you slowly or what? What? Is it that bad? I didn't think it was that bad. All right. Then where my angle is, I draw an arrow across from it. That is the opposite side. The third side is adjacent. Okay, everybody good with that? So there are 6 trigonometric ratios. It is possible you only think there is 3. That's okay. That's all you're supposed to know once you leave geometry. Sine, cosine, and tangent. Those should sound familiar to you. This is how you write it. This is 1000% not sin, cos, and tan. Makes my skin crawl. All right? And here's why. If you have a doctor, and your doctor's name is Dr. Smith, and they walk in the room, do you say, "Hey, Dr. Smith, how are you?" No, because you kind of sound like a Dr, right? You don't literally pronounce that. That is an abbreviation for doctor, all right? This is an abbreviation for sine, cosine, tangent. Don't sound as smart as you are, okay? So sine, cosine, and tangent. you always take the sine, cosine, and tangent of an angle. So it's sine of theta, cosine of theta, or sine of 30, or whatever. There's an acronym that helps us set these ratios. What is that? SOHCAHTOA, very good. Now, acronyms only help if you spell them correctly, so keep that in mind. But here's SOHCAHTOA, S-O-H-C-A-H-T-O-A. Okay. And this is what happens with it, is that this says sine is the opposite over the hypotenuse. So sine of an angle is equal to the opposite side over the hypotenuse. That's how you know how to set it up. This says cosine is adjacent over hypotenuse, A over H. This says tangent is opposite over adjacent, O over A. Okay. Everybody good with that? That's all that sound familiar? Now again, there's actually 6, not just 3. Thank you. Is it just for one person? Oh, I guess it's all for you. I couldn't tell if there was multiple people. So what you need to know, if that's brand new news to you, which it may be, then I saw it pop up in one example that I saw. Chances are pretty good most of what would be on the SAT would revolve around sine, cosine, and tangent. If you know how these 3 are related to sine, cosine, and tangent, that's all you need to know. I've been doing trig way longer than you've been alive. All right, and still, if somebody asks me about cosecant, I think about which 3 of these it relates to, and then that gives me my answer. It's not like an automatic thing. Yes. Why? What is? Oh, yeah, okay. Yeah, I feel like you're supposed to go somewhere. No, that's me. So here's how we keep this straight. These are the 3 that you already knew, right? And they are the reciprocals of the 3 that you may not know. And they are cosecant, secant, and cotangent. So you have to know how they pair up. Sine and cosine sound like they'd make a good pair, but they're 2 of the original 3, so that doesn't make any sense. But tangent and cotangent do get paired up, and they are reciprocals of each other. So if tangent is opposite over adjacent, cotangent is adjacent over opposite, right? And here I think is the best way to remember how they get paired up. Just always remember you got sine, cosine, and tangent, and then they pair up with the other 3. But in each pairing, there's only one co. So if I'm looking at cosine and trying to remember if it goes with cosecant or secant, this already has a co in it, so it has to go with secant. And if cosine is adjacent over hypotenuse, this is hypotenuse over adjacent. And then sine and cosecant, and this is hypotenuse over opposite. Okay, you okay with that so far? It's not that bad. It's really not that bad. All right. And again, they're reciprocals just like that, but because they are reciprocal functions, there's different ways we can look at it. By the way, if you think this is sin, cos, and tan, then you must think that this is sec, and cot, which makes even less sense, right? So cosecant, secant, and cotangent, like that's even more ridiculous. I don't know how to pronounce that. That was good. All right, so this which is cosecant, what did cosecant pair up with? Sine, good. So cosecant of theta is the same as 1 over sine theta. That's another way you could see it. Secant would be 1 over cosine, and cotangent would be 1 over tangent. Okay, so that's just, those are the relationships there, okay? Now, if we get through anything, and you're like, well, that was weird, I don't know if I'd remember how to do that, don't give up on me, because we're going to go from new to old, easy to more difficult, like it's going to jump around all over the place. So don't just start tuning me out if I've lost you at some point, or ask a question, that would be good too. So here, this asks for the exact values of the 6 trig functions, or it could say trig ratios. There's just kind of one and the same when you're giving answers. So here's my triangle. I know it's a right triangle because I have a right angle. Across from the right angle is the hypotenuse. This is the angle that I'm using. Across from that is the opposite side, which leaves the adjacent side. Okay. And we are going to look at sine of theta first. Sine from SOHCAHTOA is what over what? Opposite over hypotenuse. So it is 4 over 4 square roots of 5. Now, if there was a non-calculator aspect to this, we would need to be able to rationalize that correctly, do all that, but you have the calculator the entire time. If you end up getting an answer like that, and it doesn't match anything in the answer choices, I think y'all are pretty good at typing in what you have into the calculator, typing the answer choices, and finding the ones that match, right? Not the best way to teach somebody how to do this, but we got 2 days and you'll be fine. Chances are also pretty good. Your numbers may not look as weird, so don't worry about it. All right, then cosine is adjacent over hypotenuse, so that is 8 over 4 square root of 5. And we're just not going to worry about the reducing because that's a whole different thing that we can just not worry about right this second. Tangents opposite over adjacent, so that's 4/8, which we could reduce without freaking out. That gives us 1/2. Okay. So then we do the other ratios. And again, you're probably not going to be asked for all 6, but if I'm asked for the cosecant of something, I'm going to think about what the sine is and then use the sine to get me the cosecant. So it's just the reciprocal, which would be 4 square root of 5 over 4. And then that's a lot easier to reduce and figure out. It's just the square root of 5. Secant, reciprocal of cosine. So that would give me 4 square root of 5 over 8. And then I could also reduce that one, square root of 5 over 2. Not that big of a deal, right? Then cotangent's a reciprocal of tangent, so this just becomes 2. So could you set up ratios for your trig functions? They could also be variables, and we'll cover some of that tomorrow. I'm just going to start with the super basics right now. All right, so then we could be asked a question, or be given information rather, like number 5, which I know the numbers jump around too, but don't worry about it. I would suggest, and always suggest, that we draw a picture. We know we need a right triangle. It does not have to be to scale. Just don't draw it tiny so you can actually label things. Mine almost always look exactly the same just because it doesn't really matter. There's where my right angle is going to go. I have to decide between the other two where to put theta. I'm going to put it here, but then everything else matters on the labeling. Across from my right angle is the hypotenuse. Across from theta is opposite. And then the other side is the adjacent. And then it says tangent is 7 over 24. Well, SOHCAHTOA tells me tangent is opposite over adjacent, right? So tangent, opposite over adjacent, 7 and 24. Now, does that guarantee me that that's what the side lengths were? No, but nobody asked me for a side length. They're asking me for the other ratios, and the side lengths would have to be some multiple of those, or some, they'd have to be proportional. So it all works out just fine. So I know I can say, oh, this is 7 over 24. This is 24 over 7. Chances are really good that's not what they're asking you for, because that would be just way too easy. But in order for me to find sine and cosine, I have to know the length of the hypotenuse. What can I do to find the length of the hypotenuse? How do you find the missing side of a right triangle? Yes, yeah, I know, Pythagorean theorem. I know what y'all are getting at, it's all good. So 7 squared plus 24 squared equals h squared. And you have a calculator, plus it's a Pythagorean triple, but just in the interest of time, because I'm hoping that you could actually fix that and do that in the Pythagorean theorem, you're going to get that h is 25. It comes out nice and pretty. This is a 7, 24, oh, I just totally put 24 there. 24, 25 triangle. Okay. So with that information, you fill in the other 4. See if you can do that. Yes. Oh my God, just go fill it out and go. It would be 25. Yeah. Good question, because sometimes with the Pythagorean theorem, we forget to take the square root, but no, it's actually 25. So this would give me 7 over 25. And we're going to talk about this a little bit on another one as well, but how else would I know for sure that it should be 25 and not 5? Anybody? Because that's the length of the hypotenuse, right? So could this length right here be less than this length right here? No, so it would have to be more. So. Everybody good on all those? Okay, so we're still on the front. because I copied these before I was 100% sure which examples I wanted to do. So we're going to make some stuff fit in here, some other things I thought about along the way that I want to talk about. So right here, let's draw another triangle. And we're just going to label it with the same numbers, 7, 24, 25. And label this angle here X. I'm going to spare you from the other Greek letters right now. We're just going to call it X. And then because we don't need all that extra space up there, right above here is where we're going to write what we want. I want the sine of X and the cosine of X. So if you look at this, my purple triangle compared to my pink triangle, the numbers are in the same spot. Theta was down here, but I'm asking about the other angle, okay? So this is still the hypotenuse, but now this is the opposite and this is the adjacent. Do you see how opposite and adjacent just switch places? That's all that happened. And so then when I put the sine of X, opposite over hypotenuse, that's going to be 24 over 25. And cosine is going to be 7 over 25. So remember, I told you we have a right angle. The other two angles are acute, and they have to give me 90. And because of that, and because when we switched which angle it was, hypotenuse stayed the same, opposite and adjacent switch places, that means sine and cosine switch places. So when I look at this over here, the sine of X, which is 24 over 25, is the same as the cosine of theta. So the sine of one angle is equal to the cosine of the other. Cosine of X, 7 over 25, is equal to the sine of theta. So the cosine of this angle equals the sine of this angle and vice versa. That's a relationship that's good to know. If you're not 100% sure about that and that doesn't really click with you, you can always draw pictures. That works too. But just something, a relationship that I saw pop up that I want to make sure we understand. And we'll talk about more with another example. Okay, we all good at this point? Right, we're still on the front because we're going to use this little blank space over here for another example. So we're going to draw a triangle. I'm still going to use these same numbers, but I think I'm going to put them in a different place. Let me see what I have written out over here. 7, 24, 25, and we are going to label this triangle as ABC. So you would be given this information in some form or fashion, and then something like this. Triangle ABC, triangle RST. Okay, so I have triangle ABC and triangle RST that I can't see, but then I have this little symbol here. What does that little symbol mean? Similar, very good. Because here are your basic similar, or your basic symbols that work like that. You've got similarity, you've got equality, and you've got congruence, right? Same size and shape, this means they're proportional, okay? Same shape, different sizes. So this is true, and then because a lot of these are, questions that would have a lot of words in them, I'm going to abbreviate, but we're going to say the perimeter of triangle RST is half triangle ABC, which really it should say is half the perimeter of triangle ABC, but again, we don't want to have to write a bazillion things. And we want to find the sine of T. So I think we should start by drawing a picture. Now here's the thing on this. Don't draw them tiny, draw them big enough to where you can label them. And don't try to ration your paper. If I remember correctly from our official instructions on the SAT, things that we have to read and we're told we can and can't do, we have to follow very closely. It says we give you, at the beginning, you have your stuff, and we give you one sheet of scratch paper, okay? That does not mean you only get one. We are only allowed to give them to you one at a time. So don't try and ration your paper and draw things over here where you can't see what you're doing, and like ask for more paper and just keep asking for more paper, because you can't have the markers on the table, but ask for whatever you need, you will be given what you need. So we're going to draw a picture. So this is ABC. I'm going to draw another triangle, It's supposed to be smaller, but it really doesn't matter because whatever, like you're just drawing it for yourself. Mine don't even look proportional. That doesn't matter either. But here's what you need to remember about similarity, which might come up in even another kind of question that has nothing to do with trig. If you are given the statement that these two triangles are similar, the order of the letters totally matter because they tell you which ones correspond. So in this triangle, the right angle is B, and that's the middle letter. So the middle letter over here has to be the right angle, right? That's how we get corresponding pieces. And if you get to draw anything similar, I highly suggest you draw it in the exact same, the two whatevers they are, draw them in the exact same position. That way, if this is ABC, then this one would have to be RST, and then it just helps you visually as well, okay? All right, so if we know that, then, and if the perimeter of this one is half the perimeter of this one, perimeter is just adding, so that means all the side lengths are half the size. So if this one is 24, this would be 12. If this is 7, this would be 7 over 2, which is also 3.5. So we're going to do it that way too because we get calculators. And then which is 12.5. So what I've said in my other classes is, all right, so on the SAT, you get the calculator the whole time. On the AP exam, you do not. In college algebra, it depends on your professor. So we still got to know how to do things by hand because we have no idea what we're going to get. All right. And if I'm looking for the sine of t, then this is my angle right here. This is the hypotenuse. This is opposite. This is adjacent. I highly suggest you label it every time so that you don't do anything ridiculous. Then the sine of t, according to SOHCAHTOA, is opposite over hypotenuse, which you could totally put 3.5 over 12.5. But if this was a non-calculator and you had to reduce that, that could turn into a nightmare. So we are just still going to look at the fractions just because we can, because I know you can divide things out. But the sine of t, opposite is 7 over 2 over 25 over 2, because I want to continue to remind you, fractions are not the enemy. They're not nearly as bad as you usually make them out to be. So from here, all this means is division. So I'm going to do my keep, change, flip. 7 halves, change division to multiplication, and take the reciprocal, 2 over 25. Look what happens. Those cancel out. It's 7 over 25. Okay. Which is the same thing you get if you had a calculator. Well, you'd probably, on the calculator, probably going to get a decimal, but then you can make a match or whatever, and it's fine. Now, that's the actual process of working that question. If you have a true understanding of what trig values are and what they mean, you don't have to do all of that. I'm not sure that we're all going to have that deep understanding before Wednesday, so here's how you can get through it. But I want to point this out to you. Angle T corresponds to angle C. We knew that from here and from our drawings, right? If I found the sine of C, that would be 7 over 25, which is exactly what I got, and a whole lot easier to do that, right? So I guarantee you one of the answer choices is going to be whatever half of that is, since the perimeter is half. But your trig ratios, any triangle that has is similar to this one will have the exact same trig ratios. It doesn't matter how big or how small they are because they're ratios and it just evens out like that. Does that make sense to you? Even if this was twice as big, I would have gotten the exact same thing. So if you understand that, you could have jumped straight to this. Now, if you come across a question like this and you don't realize, oh, duh, I could have done that till the end, still good that we had this conversation because I know y'all like to overthink things. And then when you get that answer and you realize that that would be the same as this, but there's an answer choice where it's half of that and you decide that sounds better, that's not good, okay? So it is fine that they are the same. That is to be expected, even if you don't recognize it at the beginning, okay? Everybody okay at this point? All right, flip it over. So you have this big blank space because I couldn't make up my mind. And then I made up my mind, and we're going to break this into 4 parts, basically 4 parts. Like you don't have to measure or anything, but we have room for 4 examples, and we got plenty of room. I was trying to do things that I could see that would be similar to the types of things that would pop up for you, and maybe similar to something you've already seen on the SAT stuff if you were working through it. All right, so here's our next question. The sine of x degrees, which I think that's weird, but that's some notation I saw, so I'm going to do it the same way they did, is 5/7. And then we want to know what is cosine of 90 minus x. Now, if you're super confident and you're like a trig expert, maybe you just know the answer. But, and I've been doing trig longer than y'all been alive, but sometimes I still like to draw the pictures to make sure my brain isn't assuming something or doing something weird. So my suggestion here would be that we draw a picture. Okay, so I'm going to draw a picture. I got a right triangle. X is my angle measure, so I'm going to put an X here. Then I'm going to label, this is my hypotenuse, this is opposite, this is adjacent. And I know from SOHCAHTOA that sine is opposite over hypotenuse, so I'm going to put a 5 and a 7. Now right now, this looks very similar to the ones that were actually printed on the front. However, I'm not going to just do Pythagorean theorem for the sake of doing it because I can find the adjacent side, because it's not asking me for the cosine of x. I don't know that I even need it. It's asking me for the cosine of 90 minus x. If this is x, right here, and this is 90, doesn't this angle right here have to be 90 minus x? You with me? If this was 30, this would be 60. So x and 90 minus x, because the two angles have to add to give me 90. And so it's asking me for the cosine of this angle. For that angle, this is the opposite. Hypotenuse is still the hypotenuse. This is the adjacent. So the cosine of 90 minus x, adjacent over hypotenuse, is 5/7. That's what I was showing you on the front, that the sine of this angle is the same as the cosine of this angle and vice versa. All right, so if you kind of knew that's what was asking, then you didn't need to spend any time on it. And if drawing a picture helps you make sure you're not making up math, nothing wrong with that either. Okay. What questions we got? Because, okay, how did I know where x went? Because when I make my triangle, that's my right angle, I could put x in either place. If I put it up here, it would be fine, but then from the beginning, this would have been 5 and this would have been 7. Because that would have been the opposite. You get the same thing, you just look different than your neighbors. And it doesn't matter, because you're getting to draw it, and you're not making stuff up. Okay, good question. What else we got? All right, just made me think. I wanted to make sure I cleared that out. Okay, I did, because we're about to use that. All right, here is this one, and I'm going to make this 40 degrees, this x, and this 12, and we're going to find x. Now, it would actually probably say find the value of x, but and this is where your application from geometry really is what you probably did most in geometry. But we start off the same way. Here's the angle. Across from the right angle is the hypotenuse. This is the opposite side. This is the adjacent. Even though I'm not going to use all three sides, first of all, you don't always necessarily know that. Second of all, I still think it's a good idea, unless you're a trig expert, which I don't know that any of us are, to label all three sides, because if you make a mistake and they're all three labeled, you're more likely to catch it than if you just label two of them. But I know that I'm using, x is what I'm looking for, 12 is what they gave me. Pretty sure I'm not even going to need the hypotenuse. You don't necessarily have to mark it out, but it's just, okay, I don't need that. So I'm using the opposite and adjacent side. From SOHCAHTOA, which trig function is that? Opposite and adjacent. You can flip your paper over if you need to. Tangent, okay. Remember, you always take sine, cosine, or tangent of an angle. So this is going to be tangent of the angle, which is 40, is equal to the opposite, which is x, over the adjacent, which is 12. Okay. Now, the tangent of 40 is just some value, right? Some number. Nobody expects you to know what it is. That's why it would be a calculator question. I would think The great majority of everybody in the entire universe don't know what that is. There's probably a handful of people, but we probably don't associate with them. They're way smarter than us. All right, so basically I have some number is equal to a variable over a number. How do I get the variable by itself? Don't overthink this. Basic algebra times 12. Don't start doing weird things because it says tangent in it, okay? All I care about, on the right-hand side, to get x by itself, I'm going to multiply both sides by 12. So this is going to give me x equals 12 times the tangent of 40. So your answer choices could be in that form, with probably one saying tangent, one saying sine, and maybe, you know, the angle changing or whatever. But you could also be expected to get the actual decimal for this. So if I look at this triangle, let's talk about reasonableness of an answer. We know that the hypotenuse is the longest side because it's across from the right angle. And I wouldn't necessarily have to do all this to answer this question, but there are little things that you need to know. If this is 40, this one would have to be 50, right? Do we agree with that? So then, and that looks like 56. Which side length would have to be bigger, do you think? The x or the 12? Okay, so the hypotenuse is the longest side because it's across from the biggest angle. Another takeaway from geometry we need to know, biggest side across from biggest angle, smallest side across from smallest angle, okay? So 40 is across from x, 50 is across from 12, so 12 is going to have to be bigger than x. Does that make sense to you? If you know that much, and there's 4 answer choices, and 2 of them, the answers are more than 12, you can eliminate those, and if you're about to run out of time or don't know what else to do, now you got to get 50-50 shot, right? Not the best way to always learn how to do things, but sometimes we have just survival skills, and it's okay. All right, but if I have to actually type this in, now, if you are taking the SAT, you will be provided a TI-83 or 84. I mean, they're basically the same. If you are taking the PSAT, nothing's going to be provided for you, except everybody gets the Desmos calculator. I found, so this is the SAT one that PSAT, SAT one that I showed you the other day. I found a listing of all Desmos's testing calculators, and it gave you some information about how it might be different than just the basic one. And what it said on here was that the default was in degrees. However, when I opened this up, before I did anything, and I thought, I'm going to double check this, I went over to the little wrench for my settings, and right here is how you change it from degrees to radians. And the default for what I went to was the radians. Now, the one that's officially embedded, maybe that's not the case. For anything you do on this graph, the only thing that would make a difference for is if you're going to type in some trig stuff. Okay, so you don't have to check it for everything. But clearly we were working with degrees. So here, you know, before you do it, you can kind of make sure, okay, I need it to be in degrees, make sure it's in the right format. So now it's in degrees. So over here, I'm just going to type in what we had, which was 12. Why won't you work? Why does everything work every other time? Okay, well, it says status is green and everything. Ah, there we go. Just start banging on it and then it works. All right, so 12 times. Now, I don't have to go to a special menu. I don't have to do anything fancy for trig. That was the tangent of 40. I'm literally just going to type the abbreviation for tangent. Okay, maybe I'm not. I did. T-A-N. All right. And then I open my parentheses, type in 40. And even before I hit enter, there's my answer, 10.069. So x is equal to 10.069. Does that seem like a reasonable answer? We expected it to be less than 12. It's less than 12. That, of course, doesn't guarantee me that I'm right, but it's something. And not only that, but another relationships of sides and angles, whether it's trig or not, 40 and 50 are not that far apart from each other, and neither are 10 and 12. So I would expect something kind of close to 12. I wouldn't expect to get like 2.069. That would be way too far apart. Okay, but just little things to help you. Any questions at this point? So we're not 100% done with trig, but we're going to shift gears for a little bit just because of the way that these are laid out. We're going to come back. Oh, great. It's doing one of those things. Don't I love that? Let's see. Yeah, no idea how that, I couldn't make that happen again if I wanted to. These two blanks are actually going to be used to do more of these examples, because like I said, it was already copied. Let's see. We don't have a ton of time left, but we can get started. We can at least talk through this part. So, special right triangles. Now, I would expect you to remember even less of this most likely, but hopefully at least remember that you did it. And some teachers are very opinionated about how these should be taught. I am one of those, of course. And so who knows who taught you geometry? And it's not that anybody in essence, hopefully they didn't do it wrong, but some teachers label this stuff and they use X's as every variable. I think that's a terrible idea, and I will show you why in a minute. And then I would use S and L for short leg and just leg. But here's what you're going to get on the SAT. First of all, if you don't know that there's 180 degrees in your triangle, but it tells you. It also tells you that there's 360 degrees in a circle. So if you're second guessing yourself, look at the reference materials. If it's there, use it. There's no, you can't be like, I'm too cool, I already know. Double check so you don't mess them up. But here's what you get for the special right triangles, which is weird to me because some of it is X, but some of it is S, and I would have used S on this one, but whatever. It's the relationship that matters, not the actual letters. I think S isn't used a lot because they can look like fives. Mine look like fives a lot. So here's what I would suggest to you. This is going to be digital reference sheet. I don't know if you're able to write on it or not. But if you're going to use these relationships, change the X's, whether you're going to write it out or just know that you don't want to actually use X, or you can actually write on this, I don't know. But everywhere that it have an X, I'm going to change it to S. Not on everything, just these. And then I'm going to show you why here in just a second. If they give us a 30, 60, 90 triangle and some information and asked us to find X, and they labeled this side length as X, but then you go and label it as X times the square root of 3, do you see how that could get very confusing? Yeah, so since S isn't used a lot, S just makes a little bit more sense. But I'm going to show you how we're going to do that on what you can actually write on here. So if you have a 30, 60, 90 triangle, it will actually be mentioned that way, like said that way in the question, or it might just be labeled for you. But we know hypotenuse is across from the right angle. You also have a short leg and a long leg. What angle do you think the short leg is across from? Which is 30. So across from 30 is S. Now, again, these are already labeled for you on the formula chart, but I'm just wanting to see if we knew. And then hypotenuse is 2S. This is S times the square root of 3. Okay. The other special right triangle is a 45, 45, 90 triangle. Because it has two congruent sides, it can also be said that it is an isosceles right triangle, because that's also true. So if they say 45, 45, 90 or isosceles right triangle, they are the exact same thing with the exact same properties, okay? And these labels, which will be on your reference materials, S, S, and S times the square root of 2. So the good news is you don't have to remember where to put what, you just have to be able to use it correctly, okay? And we will start here tomorrow with these examples and then do a little bit more trig stuff. I am going to go ahead, though, and give you the paper for tomorrow, just in case you're not here.